Hello 8th graders, in this video we're going to start talking about this concept called momentum. Sometimes momentum can feel a little bit hard to get your brain around, and so I like to think of it in terms of an example. Let's say that you're trying to design some bulletproof glass, and it's your job to test it. Think about the bullet that might be hitting the glass. What are the factors that are going to impact how good the glass is at stopping that bullet? If you think about it, there are really only two things, with maybe a couple of exceptions, but the two big ones are how big is this bullet and how fast is it going. Those are the two factors that combine to make this idea called momentum. And in this video, we're going to talk about how to calculate it. Specifically, the ELR looks like this. Your job is to be able to explain how momentum is like inertia and be able to calculate it. So let's start with that glass example again. Let's say that you're trying to break through this piece of glass, but you've only got this certain size object, and it's really small. Well, if you have a really small object, it's going to have to go really, really fast to get through that piece of glass. Well, let's say that you have a much, much heavier object. Well, because it's a lot heavier, it doesn't need to go nearly as fast. Both of these objects are going to be able to break through. So if you think of the glass as like something that needs to be overcome or bashed through, if you have something small, it takes a big velocity. But if you have something big, it's just going to take a small velocity. But if you put these factors together, little and big or big and little, they both come together to make the same amount of momentum. Each of these things has the same amount of stopping power that would be required to make them stop. So in your little booklet that you should have got from the front counter, we're going to do a little bit of notes and a practice example before you get started on some of your own. So the first thing we have to do is define this. The definition for momentum can be defined a few ways. I've defined it as it's a measurement of how hard it is to stop something. You could also think of it as momentum is inertia in motion. It might be easier to see the equation. We use the letter P to represent momentum, and momentum is just the mass of something times how fast it's going. So if you think of something that's really small, like my pen, and you move it really slow, it's not going to have a lot of momentum. It's not hard to make that thing stop. But if you took something really huge, like a big giant heavy truck, and you made it go speeding down the highway, now it's got a big mass and a big velocity, it's going to be a really big momentum. It's hard to stop that thing. Those are the two extreme examples, but the real trick is to think about things in the middle. Think about my pen and that big heavy truck. Could I get my pen to have the same momentum as a big heavy truck going down the freeway? Well, the answer is yes. Because it's really small and really light, in order for it to have the same stopping out, like the same hardness to stop it, I would have to get my pen going ridiculously fast in order for it to have the same momentum as a truck going down the freeway. But you can make objects have the same momentum. Also, momentum has a direction, just like velocity. So you can say that something has a momentum to the left or to the right or north or south or whatever. Momentum is a vector quantity. It is something that has a direction and a magnitude. During this lesson, when we're calculating, I want to remind you of the triangle. It works for this one also. Here's how you would use the triangle. When you're solving for momentum, you would cover the P, and that would make M and V next to each other. That means multiply. Let's say you're solving for velocity. If you cover the V, then you have momentum divided by mass. And the last bit, if you cover the M, you're solving for mass. Then you would do momentum divided by velocity. Let's do a practice one. On your paper, I've taken off the G, the U, and the E. Your job is just to do the substitute and the solve, but I'm going to still fill in the other parts. So let's say that we have a 4-kilogram cannonball that's flying through the air at 20 meters per second, and we have to find the momentum. Well, the given information is the mass and the velocity. 4 kilograms, 20 meters per second. The thing that we're solving for in this one is momentum, and again, we use P for that. The equation is mass times velocity. And then when we substitute, we plug in those things that we need to know, and then we solve 4 times 20 is 80. Please notice the units on this. When we take mass, which is in kilograms, times velocity, which is in meters per second, we get this weird unit. It's called a kilogram meter per second. I bet you didn't know that a kilogram meter was a thing, but it's true. Kilogram meters per second is our units for momentum. Now that's quite a bit of momentum. That's a cannonball flying out of a cannon. Let's go over to the football. If you have a football that has a momentum of 60 kilogram meters per second, think about how close that is to our 80. And this football has a mass of a half kilogram. We're going to figure out how fast it's going, its velocity. Now just think about what kind of a number we should be getting. 60 is a lot of momentum. Think about whether or not this thing would have to be going fast, and it has to be going really, really fast. So our given information is the momentum this time and the mass. Of course, in this one we're solving for v, for velocity. When we use our triangle, we cover v, and that means we're going to do momentum divided by mass, p over m, in order to find our velocity. Then we just substitute and solve. We plug in our 60 and our half. 60 divided by a half is not 30. That would be 60 times a half. 1/2 goes into 60 120 times. So the velocity of this football would have to be 120 meters per second, which I think we can agree is really, really fast. Here's a real life example that I want you to think about. So true story, if you're a fan of Mythbusters like I am, maybe you've heard of this, but the Mythbusters like to do a lot of their shows with actual cannons. And one day a cannon was angled wrong or something, but basically they fired a cannonball through a neighborhood. Thankfully nobody was hurt, but here's some information about it that I found interesting. So the cannonball, I looked it up, was 5.5 kilograms, and they figured that the momentum when it was fired was 740 kilogram meters per second. Lots of momentum. I want you to think about how fast was it going. So when I looked at the news reports, here's what they figured out. It took about 4.3 seconds, and what it did was it crashed through a house, bounced across a road, and then off of another house's roof, and then right through a minivan. That was its whole little trip, and it did all of that in 4.3 seconds. If we want to figure out how fast was it going and how far did it go if we kept up with its same velocity, all that kind of stuff, we can use our momentum equation to do this. So think about it like this. Our equation would be momentum equals mass times velocity, and they told us the momentum was this big, huge number, and they told us the mass. We could figure out how fast that cannonball was going, which was 134.5. Now, reaching way back in time, we have done velocity equations before. We can even use that information that we just found, the velocity of the cannonball, to figure out how far it went when it was bouncing across all this stuff in these people's neighborhood. We would just plug it into our velocity equation. We could put in our velocity equals displacement divided by time, and we could figure out how far it went. This is a good example of how physics equations can be used with each other to figure out different information. Now it is time for you to pause this video. In your booklet, there are 3 questions that I need you to answer. Please pause this video and come back when you're ready to check your answers. If you're still watching, you're ready to check. The first one, how is momentum related to inertia? Well, remember, momentum is mass times velocity. So if mass and inertia are the same thing, the equation for momentum, you could rewrite it by saying momentum is inertia times velocity, or inertia in motion is another way to think of it. The second one, can something with momentum have no inertia? In order to have momentum, you have to have mass that is moving. That's what momentum is. Well, since mass and inertia are the same thing, you can't have an object that has momentum but no inertia, because inertia is mass. And then the last one, how is it possible for 2 very differently sized objects to have the same momentum? Imagine you have this tanker ship that's probably thousands and millions of kilograms, and it's just chugging through the water pretty slow, but it has a lot of momentum. It is really hard to stop a ship like this. And then you have a tennis ball. In order for these objects both to have the same momentum, there's basically 2 ways. Either they're both stopped, then they both have 0 momentum, because it's not hard to stop a thing that's not moving, it's already stopped. Or this tennis ball has to go really stinking fast, like really, really fast. Now it is your turn to go and do some practice. In Google Classroom, I have left you some slides, or you can choose to do this in the rest of your booklet. Either way, they're the same questions. Here's how it works. Here's what the slideshow looks like. The instructions are on the first slide, but I'm just going to describe it to you. There are a few slides, 5 of them, where he's giving you different questions. On each slide, there's a level 1 and a level 2 option. The level 1 is a little bit easier, and the level 2 is a little bit more challenging. As you go through these, it's up to you to choose the one that makes the most sense. I need you to show your work though. As you're working through, I need to see at least your substitute and solve steps in order to make sure that you're on the right track. If you're having trouble with any of these stations, there's a link right here where it says Station Answer that'll show you not only the answer, but also how I got there. If you're working in the booklet, the pages look like this. It's basically the same thing. I recommend that you work in the booklet because the booklet is going to be a lot easier to take with you into the test. However, I'm going to let you work whichever way you want. When you are finished, the last step of this lesson is to go into the Google form that is linked in Google Classroom that is called the Momentum Closure. Please make sure to check your answers after you submit it. There's a button to check your answers when you are finished. Ready to go?